Hello and welcome back to Engineers Olympiad, where learning meets success. We're doing the numericals of the second chapter of surveying, that's theory of errors in surveying. So let's begin. Question given is the long and short sides of a rectangle measure 8.28 meters and 4.36 meters with an error of plus minus 5 mm. Express the area to correct limits. All right, we have to express the area to correct limits. Let's do the question. Area of this rectangle is equal to 8.28 meters multiplied by 4.36 meters. The long side multiplied by the short side, that is equivalent to, my calculation, 36.1008 meters square. All right, so this is the area of this rectangle, which measures 8.28 meters and 4.36 meters, one being its long side and the other being its shorter side. All right, so we have expressed the area. It is 36.1008 meters square. But we have to express the area to correct limits. That is, we have to take this thing into consideration. Each side has an error of plus minus 5 mm. All right. So we have to calculate the combined effect of this error in the individual measurements. All right. So as per the general expression, we know that error in area is equal to, when we have to do the product of two quantities, since area is the product of the longer side multiplied by the shorter side. So standard error in area is equal to, by the general expression, in case of product of quantities. Hello and welcome back to Engineers Olympiad, where learning meets success. We are doing the numericals of the second chapter of surveying, that's theory of errors in surveying. So let's begin. The question given is the long and short sides of a rectangle measure 8.28 meters and 4.36 meters with an error of plus minus 5 mm. Express the area to correct limits. All right. The area of this rectangle is short side multiplied with the longer side, that is 8.28 meters multiplied by 4.36 meters. This is the area of the rectangle. All right. By calculations, it is equal to 36.1008 meters square. All right. Now, the question says express the area. Since we have expressed the area, but to correct limits, that is, this thing will come into play. Each side, the longer side as well as the shorter side, has an error of plus minus 5 mm. So we have to calculate the effect of the error on the individual observations on the combined effect, their combined effect on the derived quantity, that is the area. That is, we will use the general expression when we are doing the product of two quantities. All right, because area is the product of two sides in case of a rectangle. So the general expression to be used is, that is, area, error in area is equal to how much? It is plus minus AB under root of sigma A divided by A square of it plus sigma B divided by B square of it. All right. This is the general expression for the propagation of errors when the product of two quantities have to be done. All right. So I'll substitute the values. So error in area is equal to plus minus one side, A being the one side and B being the second side. This is 8.28 meters multiplied by 4.36 meters. All right. Sigma error in one side is also equal to error in the other side, and each have an error of plus minus 5 mm. For dimensional homogeneity, I will convert it into meters. It is 0.005 meters. Divided by A is how much? 8.28 square of it plus sigma B is also 0.005 meters divided by B. It's how much? It's 4.36 square of it. All right. So by using the general expression for the propagation of errors, my answer is plus minus 0.04 meter square. All right. By calculations, my answer is equal to plus minus 0.04 meter square. So by this time, I have expressed my area, that is 36.1008 meter square. and I have also calculated the error in area. Now I have to express the area to correct limits. Now area is 36.1008 plus minus 0.04 meter square. Alright, so I have expressed the area to correct limits. It is 36.1008 plus or minus 0.04 meters square. It lies somewhere between the two values. Its limits are between plus and minus 0.04 meter square. Alright, moving on, let's do the next question. We're trying to solve as many numericals as possible. All right, so let's do the next question, question number 2. All right, so the question number 2 says a rectangle has sides approximately 380 meters and 260 meters. If the area is to be expressed, if the area is to be determined to the nearest 10 meter square, what will be the maximum error permitted in each line? What would be the maximum error permitted in each line and to what accuracy should the lines be measured right? Assume equal precision ratio for each length. Equal precision ratio for each length. All right. So the question says a rectangle has sides approximately 380 meters and 260 meters. If the area is to be determined to the nearest 10 meters square, what would be the maximum error permitted in each line and to what accuracy should the lines be measured? We have to assume equal precision ratio for each length. All right. So let's do this. Area of this rectangle is 380 meters multiplied by 260 meters, all right, which is equivalent to 98800 meters square. All right, this is the area of this rectangle, which has sides as 380 meters and 260 meters. All right, now it says if the area is to be determined to the nearest 10 meters square, that means maximum error in area to be permitted is right, how much? 10 meters square. All right, let me calculate the precision ratio for area. That is delta A divided by A. this is 10 divided by 98800. This is a dimensionless quantity, and this is equal to 1 by 9880. All right. This is my precision ratio for the area. All right. Wherein we have been told that area is to be determined to the nearest 10 meter square. That is, maximum error in area is 10 meter square. I calculated the precision ratio in area and it came equivalent to 1 by 9880. All right. Let me rub it first so that we can proceed. All right, I have been given two lengths of a rectangle, 380 meters and 260 meters. Let me assume the one is x and the other is y. All right. That means precision ratio in area is equal to how much? Summation of precision ratio in the individual lengths. All right. All right. But we have been told that we have to assume that there is equal precision ratio for each individual length, that is delta x by x is equal to all right. We have been told that we have to assume that there is equal precision ratio in each individual length. That means delta x by x is equal to delta y by y. All right. So we know that delta x by x plus, so I'll substitute this over here. Let me rub it first. I have taken my one side as x and the other side as y. Precision ratio in area is equal to, all right. But since we have been told that we have to assume equal precision ratio for each length, that means this quantity and this quantity, they are equal to each other. Then I may write it down as this. All right. All right. That means that we have calculated this. It was how much? It was 1 by 9880. All right. We already calculated precision ratio in area. That means our delta x by x is equal to all right. Hence, precision ratio of each line is 1 by 19760. All right, I may write it down. Precision ratio of each line is 1 by 19760. All right. Then it asks us what should be the maximum error permitted in each line. That means maximum error permitted in this length 380 meters is how much? Multiplied by the precision ratio 380 divided by 19760. This is equal to 0.0192 meters. This is the maximum error permitted in this length. Similarly, maximum error permitted in 260 meter length is equal to how much? 260 meters divided by the precision ratio 19760, which by calculations is equal to 0.0132 meters. All right. So we calculated the maximum error permitted in each individual lengths as well as the precision ratio of each line, which was same, because we had to assume that there is equal precision ratio for each line, and that was equivalent to 1 by 19760. It also says us something. It says us to what accuracy should the lines be measured. All right, we have calculated this thing, maximum error permitted in each line, but it also says, and to what accuracy should the lines be measured. If the number of significant figures in area is 5, because my area was equal to how much? Let me write it down over here. Area, we calculated area of this rectangle as 98800 meters square. How many significant figures it has? It has 1, 2, 3, 4, 5 significant figures. All right. So if the number of significant figures in area is 5, then each line must be measured to at least 5 significant figures. All right. Each line must be measured to at least 5 significant figures. That is 380 I have to express it in 5 significant figures. This will become, all right, both have been expressed to 5 significant figures. All right, because it's the general rule that when the numbers are either multiplied or divided, the result has significant figures equal to the least number of significant figures of the individual numbers. Similarly, we have been asked to what accuracy should the lines be measured. Since area had 5 significant figures, then each line must be measured to at least 5 significant figures. That means this becomes 380.00 meters and this becomes 260.00 meters. All right, going on, let's do the next question. We're trying to solve as many questions as possible. We are doing the same thing in each and every chapter. And similarly, in this chapter, Theory of Errors and Surveying, we're also trying to solve as many questions as possible. Question number 3 is, if the standard variation is 1 second, then the maximum error would be. All right. The question is, if the standard variation is 1 second, the maximum error would be. We know that maximum error is given by E99.9, and this is known as 99.9% error. And it's expressed as E99.9, and we know that it is equal to plus minus 3.29 times the standard deviation or the standard error or the standard variation, because standard variation, standard deviation and standard error, they're all one and the same thing. All right, So maximum error is equal to plus minus 3.29 times the standard variation. It is plus minus 3.29 times, how much is my standard variation or standard deviation or the standard error? 1 seconds. That means my maximum error will be plus minus 3.29 seconds. All right. And we also know that in surveying, generally 99.9% error is taken as the maximum error, because it's impossible to estimate the absolutely maximum error, as that would occur at infinity. And this maximum error, it corresponds to a range of plus 3.29 sigma to minus 3.29 sigma. And this maximum error is often used to separate mistakes from the gross errors, mistakes or the gross errors from the random errors, because if any measurement deviates from the mean by more than plus minus 3.29 sigma, that measurement is considered as a mistake and hence it's rejected. All right, moving on, let's do the next question. Question number 4, it is if the standard error in a quantity x, if the standard error in a quantity x is 1 seconds, then the standard error in 4x will be. All right, if the standard error in a quantity x is 1 second, the standard error in 4x will be. We know that from the propagation of errors, if any quantity is multiplied by some constant k, the error in the quantity is equal to k times the error in the observed quantity. All right, that means if sigma in x is how much, 1 second, then in 4x will be the error in the first quantity, that is sigma x, multiplied by the same constant by which that quantity has been multiplied. So it will be 4 times sigma x. All right, so sigma in 4x is equal to 4 multiplied by 1 seconds, that is 4 seconds. All right, so the general rule is, if a computed quantity is equal to an observed quantity multiplied by a constant k, the standard error of the computed quantity is equal to the standard error of the observed quantity multiplied by the constant k. Here the constant k is 4 and the observed quantity is x. All right, and the computed quantity is 4x. Moving on, let's do the next question. Question number 5. If the standard deviation is plus minus 1 seconds, E 99.9 is equal to. All right, so the question is, if the standard deviation is plus minus 1 seconds, then E 99.9 is equal to. All right, we know that E 99.9 or 99.9% error is known as the maximum error, and it's equal to plus minus 3.29 times the standard deviation or the standard variation or the standard error. So this is equal to plus minus 3.29 times standard deviation, that is given as 1 seconds. So E 99.9 is plus minus 3.29 seconds. All right, moving on, let's do the next question. We're trying to solve as many questions as possible. All right, let's do the next one. All right, we have to determine, this is question number 6. We have to determine the significant figures in each of the given numbers. Determine the significant figures determine the significant figures in the following. Numbers. All right. Determine the significant figures in the following numbers. How many numbers we have? We have 5. The first one is, let me write it down first. Second is then we have right? We have been given 3 numbers. Sorry, we have been given 5 numbers and we have to determine the significant figures in all of these numbers, all right? The first one is having how many significant figures? 1, 2, 3, 4, and 5. Before that, let me recapitulate about the significant figures and the zeros that are involved. Zeros at the beginning are not significant. Zeros between the digits are significant. And zeros at the end are significant. So zeros between the digits are significant. That is, this 0 is significant. That is, this number has 1, 2, 3, 4, and 5 significant figures. Next one. This has how many significant figures? It has 1, 2, 3, and 4. All right. 1, 2, 3, 4. By the same rule that the zeros in between the digits are significant. Next one has how many significant figures? 1 and 2. Why? Because zeros at the beginning are not significant. Zeros at the beginning are not significant. That's why the 0 is not significant, and hence this number has only 2 significant figures, 1 and 2. This 0 being at the beginning is not significant. Next one, 14.0. How many significant figures? It has 3 significant figures, 1, 2, and 3. Why? Because zeros at the end are significant. All right, zeros at the end are significant. So it has how many significant figures? It has 3 significant figures. All right, let's do this one. This has how many significant figures? It has 1, 2, 3, 4, 5, 6, and 7 significant figures, because this 0 being at the beginning is not significant. This was at the beginning, this was not significant. The zeros at the end are significant, and zeros in between the digits are significant. All right, so this number has 7 significant figures. All right, let me summarize it once again. For all non-zero digits, they are significant, but zeros at the beginning are not significant. Zeros between the digits are significant, and zeros at the end are significant. All right, so this is about the significant figures. Moving on, let's do the next question. This is question number 7. All right, let me drop it first.